Hi. Now we're into the IP layer, talking about the IPv4 and some of the IPv6 addresses. Most of this actually I think is going to be IPv4 addressing. So the next two chapters are IPv4 and IPv6. So we're going to talk about the subnet mask, prefix lengths, things of that nature, along with subnet masking and how to generate subnets, how to split this address that we have to isolate smaller networks. So there are 7 sections in this. I'm not sure I'm going to make 7 videos. I'm probably going to see how long each one lasts, and then so you'll probably see 4, maybe. We'll see. So if we look at the IPv4 address, so you know it's a 32-bit architecture. So you got an address, and how do I know when I look at an IP address, 192.168.10.10, how do I know which of that is network, addresses that the network gets in, and which part handles the host? Well, that is done by the subnet mask. Now, we've all done this binary address configuration, and we know that each octet has 8-bit representation. So when you're doing that decimal to binary configuration, you got to make sure it's an 8-bit configuration for that octet. So there's a network portion to an IP address, and there's a host port. The question is, how do I know what is what? Well, the way you do that is through the subnet mask. And the subnet mask basically is only purpose in life is to identify what's the network portion and what's the host portion. Now, the easy thing is, if you want to know what's network, what's host, look at the subnet mask. If the subnet mask's bit is a 1, it is network. If it's a 0, it's host. Now, one good thing about the subnet mask, unlike the IP address, all of these 1s and 0s are consecutive. So there'll be a string of 24 bits to represent the subnet mask and a string of 8 zeros. You'll never see the 0s and 1s interspersed amongst each other in a subnet mask. You got a string of 1s and a string of 0s. Now, if you're configuring your IP address, you've probably done this a couple different ways in the labs. And either you've done it through IP automatically, where the DHCP provides all the information, or you specify the address itself. And you get an IP address and a subnet mask, also a default gateway and a DNS if necessary. But that subnet mask, as you can see in this example, you see 255, 255, 2550. That 255 represents what? 8 consecutive 1s. So I've got 8 consecutive 1s, 8 consecutive 1s, 8 consecutive 1s. So there's 24 network bits out of the 32. So that tells me that the network that I'm dealing with is the 192.168.10 network. Anything in that last octet, from item 1 to item 254, 255, 254, is a host address in the 192.168.10 network. So just note, so this gives you a rough idea. So what is that? Again, we said what? Consecutive 1s, 255, 255, 255, 24 consecutive 1s, and the 0s for the host bits. Now the question is, how do I associate an IP4 address and its subnet mask? Well, what you end up doing is pretty much put one on top of the other, and what you'll do is what they call an ANDing organization or operation. And if there are 2 1s, it considers a 1. If it's a 2 0s, it's 0. If it's a 1 and a 0, it's a 0. Just so in this case, when I'm ANDing these together, When I see the ones, I just automatically pull down 192.168.10, all because of what? The 255. There's only ones there. Now, if for some reason, maybe it was 255, 255, 240, which then would be, once you do your binary, which bit is turned on and how many bits are turned on to get to 240. And of course, you knew it right off the top of your head when I said that, there's 4 bits. So then you'd say, okay, what are the 4 bits? And now if I ANDed those 4 ones into that 10 address, there's 4 zeros. So the network portion would be 192.168.0 would be the network portion that we're dealing with. So just this ANDing procedure, if it's a 1 and a 1 in the subnet mask, you automatically carry it down. If it's a 1 and a 0, it's a 0. If it's 2 zeros, it's a 0. So now some operations will actually give you a prefix length because the subnet mask it's confusing to write out. 255, 255, 255. A lot of effort. So they've gone to a prefix length. Plus, you're also going to see this in IPv6 because there's so many bits. Prefix lengths just made more sense. So when you see a /8 prefix, that's telling you the number of bits, the number of network bits in the subnet mask. So in that example there, you see /8, that ends up being a 255.000 network. Or what do you see? I see in that subnet mask, I see 8 network bits. When I see a /16, you got 16 network bits. 24, you got 24 net bits. You see the other examples, 26, 27, 28, and all I'm doing is keeping, and all it is the prefix length matches the number of ones in the subnet mask. Now, determining the network, this is where you talk about this logical AND, that if both the subnet mask and the IP address have a 1 in that bit location, it's a 1. Any other combination, it's a 0. So you'll be able to figure that out. So it's not. So and all you're doing is you look at the first bit of the subnet of the IP address and the first bit of the subnet mask, 1 and 1, bring down the 1. And that goes all the way through till you get down to somewhere here into that last octet, where now you've got a 0 and a 0. I bring down a 0. And when you see the other addresses here, you got in these 4th and 2nd bits, they're all zeros in the subnet mask, they end up coming down as all zeros. So just keep in mind, if it's a 1 and a 1, you bring it down. If it's anything else, it's a 0. Take a look at that video, and I think there's some exercises that, let's see, if my computer would respond in a timely fashion. And I would, let me just watch that video. Let me bring a couple extra. Bringing this one. Now, there are 3 types of IP addresses. There's a network address and a host address, and we figured that out based on the subnet mask. The last one is the broadcast address. And you remember when you said, gee, I don't know information about a particular device, and you had to ask for information to get MAC addresses and stuff. What did I have to do? I had to send it a broadcast address. Well, when you looked at that address, what was the broadcast address? It was all Fs. So in this case, you look at, and that's what I'm saying, this broadcast address is what gets addressed out. Now, some of the homework you're going to be asked to do is based on the subnet mask. What is the host? What is the network address? What's the first usable address? What's the last usable address? So right off the bat, if you've got a subnet mask of 255, 255, 255, and all zeros in the host portion, and you have a network address of 192.168.10.0, you do that ANDing operation, you get what? I get a network portion of 192.168.10 is my network. The hosts are all zeros. But now the question is, which of these hosts can I use? You can't use for a device, you can't use anything in the host portions that's all zeros, and you can't use anything in the host position that is all ones. The all ones is a broadcast address. The all zeros indicate that it's a network address. So as far as usable addresses in a subnet, you can say the maximum number of addresses usable -2, because I can't use the all zeros and I can't use the all ones. So the question is, what's my first usable? Well, it's your network address +1, and then for the last usable address, it's your broadcast address -1. We'll get into a little bit better explanation, an easier way to calculate this shortly. But I just want to get those definitions out there. So there are first and last usable hosts. So it's the first host within a network is the first usable. The last host is the last host within a network that is usual. And then, as we said, the broadcast address is the ones that are all, well, the host address are all ones. I would go ahead and do these practice exercises, and I would actually do some of the quizzes here just to make sure you understand how all this stuff comes together. So I think what I'll do is I'll go on to I'll stop this video and I'll start a new one with the unicast, broadcast, and multicast.